Hi everyone. In this tutorial, we are going to show univariate regression approach for forecasting time series with seasonal decomposition. We're going to do it in 4 steps or 5 steps. So step 1 is to calculate seasonal index by dividing period average with total average. So here first, before going to the first step, let me show you the setup. So we have the date, we have this variable, this is what we're going to forecast. This is Baltic Cape Size Index, route C3, Turbaro to Qingdao, 160,000 to 170,000 deadweight tonnage vessel. This is the freight rate per ton. It can be any time series. It can be sales, it can be weather. It can be anything that you are trying to forecast. Anything that has seasonality in it. And you don't have a lot of data of the input variables. So those are the things you can actually forecast using this approach. Here, we're going to use period as one of the input variables. So that's why we just created it based on the data periods we have. So it's very simple. So we start with 1, we go up to all the periods we want. Okay, in our training sample, we have 60, 5 years of data, 12 months. But then we just created some more periods for the next 2 years, that we can use for predicting the future. Okay, so this is our setup. We are first going to calculate the seasonal index, then we are create a deseasonalized index. So this is our step 1, this is our step 2, then we will make step 4 for deseasonalized forecast, and then we will make the main forecast by multiplying the seasonal index with actual data. Okay, actual forecast data. So that's how we are going to do it here. This is how our data looks like so far. We don't have anything in the forecast plot, so we'll get something there. So step 1, let me bring this a bit closer. So if I bring them here, we can see a bit more of it, right? So we calculate the seasonal index by dividing period average with total average. So here we are going to calculate the seasonal index. So for us, because it's a 12-month data, monthly data, our period averages are on month level, right? So we start with the average command, and here we take all the Januaries. Okay, so we take all the Januaries. We will have 5 Januaries, right? So we take the 5 Januaries. Here you see I'm taking them with comma. In some computers, you might have to use semicolon, right? So have that in mind. Whatever is guiding you here in the equation path, have that in mind. Okay, so this is our average of all the Januaries, and we are going to divide it by the average of the total data set. So total training data set that we have. And our total training data set ends here. This part from January 24, we are going to forecast it. We don't have the data of that, right? So we just divide it by that. And here we have to fix this part in the later parts, So in my keyboard, I use the button Fn plus F4 to fix this part, and then do the same here to fix this part. Enter. So this is my seasonal index, and then I can drag it down. So we get the seasonal index for 12 months. So basically what we got here is that, if the January values on average in our training data are higher or lower than the whole data set average. So that's what we are getting. If the value is more than 1, it means the value is higher. Like, for example, we see in May, June, July, these months have higher than the average, and also this, and rest of the months have lower than the average. Okay, so like February is significantly lower, right? So that's what we are getting. And we already utilized all the data, so we cannot get really more seasonal index. So we are just going to copy paste it for the next periods, for all the periods after that. So we are just going to duplicate it. Okay, I'm putting it as numbers. So you can put it also in the training part of the data set. Okay, so in the test part of the data set. Okay, so wherever you are going to do some forecasting and so on, you can also put it there. Okay, nice. So our step 1 is done. Our step 2 is divide the series by seasonal index to deseasonalize. So here we are just going to divide our original series by the seasonal index to deseasonalize it. And we can do it until, so we can just drag it until this period, right? Our training data set period. Actually, I think it is a good idea maybe to make it like a box so that we know this is our sample period. Okay, that's done. Step 2 is done. Step 3 is to estimate a regression with deseasonalized series. So that's what we are going to do now. To do that, we go to data. We take the data analysis tool from here. And we go to regression. Here in our input range, we are going to select the deseasonalized cities. Input Y range, so this is our dependent variable, and in the input X range, which is our independent variable or input variable, we take the period of this part. Yep, up to 60. Okay. Here we have taken the labels of the series, so I take here labels, and we want the output maybe somewhere, let's say somewhere here maybe. Okay. That should be okay. We can still access it from there. Nice. So this is our regression output. This variable has a 15% R square, so it explains 15% variation in the freight rate. It's not a very good model. It doesn't have like 70, 80%, 90% accuracy, but it can explain a little bit. So I mean, yeah, it has some explanatory power, and we can compare with MAPEs and RMSEs and see with the other models where it stands. This approach can be considered as one of the benchmark model, So we use this as a benchmark model, and the idea would be that our machine learning models and advanced model perform better than this. Okay, so now we are going to use this information for making the forecast. So we come to deseasonalized forecast. So we are trying to now, we are in the step 4 using regression for this, making forecast using the regression estimates. So we take the intercept. We have to fix this cell with Fn and F4 plus. We are going to multiply the period coefficient, which we also have to fix. It will be multiplied with the period that we have. Okay, so with the period we have here. So for the first, the period variable is this one. Okay, that's it. And that we drag it down. And here we can actually go beyond the period of training and up to the periods we want to forecast. Like we maybe want to forecast the next 2 years. So we can do the forecast there. Now in step 5, we are basically going to multiply our forecast, the deseasonalized forecast with the seasonal index to get our forecast to the actual forecast level. Okay, so we just multiply it, and then we can get it until this part here. And this is how you see our forecast is now mapped here. So we have the forecast for the next 2 years. We might want to see the error metrics for this forecast, especially for the training sample part. So to do that, we can just basically go to, we can calculate the error by actual minus the forecast. So we get the error. We can do it only for the training part. Then we can simply square the error by multiplying it with itself. And then we can also take the absolute error. So we have the error, we have the absolute error, and then we can also calculate the absolute percentage error by dividing it with the actual value. Okay. These ones, we can reduce them to 3 digits, and then we can drag it down. Right. So here, if we take the average of them, I think my command is not the correct one. It should be average. This is my MAPE. It's 21.9%, almost 22%. So it's actually bad MAPE. And if I go to squared error and also take the average of it, this is actually my MSE, mean absolute MSE, mean absolute error. And if I do the square root of it, we get the RMSE. Here we have the RMSE. So this is my mean squared error, and this is my mean squared error, root mean squared error. So we actually see that our MAPE, so if I convert it to percentage, 21.86, so that's pretty high. MAPE, RMSE, these are actually pretty high. The lagged regression approach, when we did that, oops. In the lag regression approach, we need that we had a MAPE of 10.5%, right? So we had a MAPE of 10.5% and RMSE of 2.9. So our lagged approach gives us much more accuracy compared to the univariate approach here. But at least we know now how to do univariate modeling. In case we do not have a lot of data, for the lagged approach here, we had to have a lot of data, input data, right? But in the univariate regression, we could have done one more thing. We could have actually lagged because we have this dependent variable. We could actually use also the lag of it as another variable in addition to the period, and then we could see actually how it works. But then it will not be a univariate. Yeah, actually it will be still univariate because we still rely on the data of one series and use it in different ways for prediction. But okay, so now you know how to do univariate regression approach for forecasting. Good luck. Cheers.